All right, in this video, what we're looking at is we're solving simultaneous equation, or what we call systems of equations. All right, so what I'm going to do is I'm going to be eliminating and substituting depending. All right, so this question though, this is question one. When I get question one, if I focus on the x variable, I do realize that the numeric value is the same. Mark you, one is -4, one is +4. Numeric value I'm referring to is 4. And because both of them are 4, I'm able to eliminate that x, right? The reason why I wouldn't focus on the y's, I'm looking at two different numeric values there, and I would have to do some form of work to kind of get them to be equal. But at this moment, luckily, I'm seeing the numeric values are the same for the x, which means I intend to eliminate the x's, right? So let's eliminate x. Now, if we're going to eliminate x, think about it. One is -4, one is +4. When the signs are different, we add, okay? So the signs are different, we add for it to become 0. So let us put it together. -4x plus 4x, and I'm writing everything, minus 2y plus 8y, and this is equal to -12 plus -24. So I'm adding both equations. So as you could see, when I do that, this part becomes 0 because -4x plus 4x becomes 0. So -2y plus 8y becomes positive 6y, and this is equal to -36. So -12 plus -24, that is -36. At this time, I'm just going to divide both sides by 6. So we're definitely seeing here that y is equal to -6. As you can see, 6 into itself is 1. 6 into 36 is 6. So we're looking at -6. And this is one of the values of that. Okay, so now that I know that, what I could do here, I could take that value, okay? I could take y is equal to -6, and I could substitute that value in any one of these equations here. So let us say I intend to substitute it in -4x minus 2y equal -12. So let us say I'm going to substitute -6 here, okay? I'm going to place -6 there so that the y would have now been gone, and then I solve. So let us take a look. So we're dealing with -4x minus 2, and then I'm going to replace that y with -6, and this is equal to -12. Now, let's put it together. -4x, but when I multiply -2 times -6, I will get +12, and this is equal to -12. Now, finally, if I subtract 12 from both sides, because the intention is that I do want to isolate my x term right there. So I'm going to have -4x. When the negative and the +12 go together, we'll get 0, so they're gone. We have -24 on the other side. If I divide throughout by -4, then we're able, on the left side, we'll get x is equal to +6. So the solutions to this is x is equal to 6, y is equal to -6. And there we go. And that is our first case. And in this case, you saw where we actually have the x values, the numeric value was the same, and we were able to just move along. Let's take a look at the second example. Okay. In example 2, what we're noticing is we have different values for our x. One is a 1, because if you do not see a number in front of a letter, it means that it's a default 1. But when I look at this, you could see that we're looking at the same thing. So basically, this is a -1 and a +1 there. So because I'm noticing that for the y term, we have the same numeric coefficient, right? That same numeric 1, marking 1 is -1 is positive. We are now able to say, okay, what I could do is to add, because if I have a -1 and a +1, if I add these, I'll get a 0. And that is the intention. The intention is to get one of them to be eliminated, to be gone, so we could focus on 1. So let us add these two equations together. So basically, x plus the 2x minus y plus y is equal to 11 plus 19. So in this case, I just simply added both equations. So let us see what happens. When x is added to 2x right here, it becomes 3x. But here, where we have negative y and a positive y, that becomes a 0. So this is now equal to adding these two together, and we're going to get 30. Okay, so we got our 30 right here. Now, I want to find x. We have 3 times x, so I'm going to divide both sides by 3. So definitely x is equal to 10. So here it is, I've found a value for x. Now that I've found a value for x, what I could quickly do is to take that value for x, and I could select any one of these equations. I'm going to select the one at the top. So I'm going to select that one at the top where x minus y is equal to 11. Now, bear in mind that I do know a value for x. X is equal to 10. It means then I could plug 10 where x is, right here. And then I'll just keep working. Let us see. So x is 10, so I'm going to have 10 minus y, which is equal to 11. Remember, the aim is that I want to find y, so I need y to be by itself. So I have two options. I'm just going to execute one. Let us subtract 10 from both sides here. So if I subtract 10 from both sides, then this becomes 0. I'll have negative y, which is equal to 1. Remember, I need y, not negative y. So basically, I could just multiply the entire system by negative 1 so that the y becomes positive y and the 1 on the other side becomes negative 1. So here is my y value. So the conclusion is that x is equal to 10 and y is equal to negative 1. Now, this one is different from the two that we just did. The first two we looked at, we were seeing where for the variables we saw common coefficients in terms of the numeric value. So this is different. I'm seeing a 5, I'm seeing a 10, then I'm seeing a 1, and I'm seeing a 7 right there, or negative 7. The bottom line is that I'm going to have to work on this. I could pick on the x's. So my question is, what could I do to the 5 to turn it into the 10? So I could just pick on that. So I'm going to do that. So I could multiply the 5 by 2 if I want. Okay, so I'm going to multiply the 5 by 2. So let us call this one equation 1, and let us call this equation 2. So technically, I'm creating a third equation this time. And in this third equation, I'm going to make an effort to multiply equation 1 by 2. And I'm doing that because I realize that 5x times 2 will give me 10x. And the moment my two coefficients are the same numeric value, then I'm good to go. So let us go ahead with our multiplication. So when 5x is multiplied by 2, it becomes 10x. When y is multiplied by 2, it becomes 2y. And when 9 is multiplied by 2, I get 18. This is my third equation. Now, if we observe equation 2 and equation 3, let me write equation 2 below this. So it is 10x minus 7y, and this is equal to negative 18. If you take a look right now, we do realize that my x coefficients are the same. But what can I do? If I have a positive 10 and another positive 10, because the signs are the same, if I subtract, then I'll get a 0. And that is the intention. Because when I get a 0, that entire variable x will be gone. Let us do that. I'm going to subtract, so it's 10x. I'm going to subtract 10x. Then positive 2y, I'm going to subtract negative 7y. Now, I'm going to put a parenthesis around the negative 7. There is a subtraction sign that I had to put there just as though I put this here. So that is from me, okay? So we don't want to mix those up. All right. And this is equal to 18 and then minus, but there was a negative 18. So I'm going to put a bracket around this so we could see the difference. Now, when we have a 10x minus 10x, that becomes 0. So the x variable is now gone. Now here, two negative signs clash, it becomes a plus. So basically, I have 2 plus 7, and this is going to give me positive 9. And this is equal to, take a look over here. Two negative signs clash, it will becomes positive. So 18 plus 18 becomes 36, which is to divide both sides by 9. So you could see that y is equal to 4. So here's one of my response. I have y is equal to 4 here. Now that I know that y is equal to 4, what I can do is to take that and use it, all right? So I'm going to use it in equation 1. So 5x plus y is equal to 9. But remember, I know that y is equal to 4, which means I'm going to substitute y right there. I'm going to substitute 4 for y. Let us rewrite this. 5x plus 4 is equal to 9. So right there, you're seeing 5x plus 4 is equal to 9. Now let's subtract 4 from both sides. So 5x, this becomes 0, is equal to 5. 9 minus 4, that's 5. Let's divide both sides by 5. Divide both sides by 5. So we're getting that 1x, which is x, is equal to 1. So the conclusion is this, that x is equal to 1 and y is equal to 4. Okay, so in this final example that we're looking at, there is no integer that I could multiply this by to give me a 4 or vice versa, or try to turn the 8 into a 9 or vice versa. So basically what I'm going to do now is a different method. So let us label this as equation 1. Let us label this as equation 2. So what we could do is to pick on the one that I want to eliminate. It's up to me. So let us say I want to eliminate the y's, all right? So I want to eliminate these so they're gone. So we're going to pick on the coefficients of these, right? So this is an 8, this is a 9. So what I'm going to do is I'm going to use them to multiply by the old equations, but I'm going to flip them. For example, the 8 is from equation 1. I'm going to use it to multiply by equation 2. And the 9 from equation 2 will be used to multiply by equation 1. So I flip them, I interchange them, as you could see. So now, having done that, what I'm going to do is create 2 more equations. So let's go. So 9 will be used. 9 times 7, that is negative 63 here. So 9 times negative 7x is negative 63x. And 9 times negative 8y is negative 72y. And this is equal to 9 times 9, and that is 81. This is my third equation. The fourth equation, 8, will be used to multiply throughout the second. So 8 times negative 4, that's negative 32x. 8 times 9 will give me positive 72y. And 8 times 22, negative 22, that's going to give me negative 176. And this is my fourth equation. Now, if you observe now, you do realize that because we picked on the y coefficients, I was able to get the same numeric value now when I flipped the numbers that I used to multiply my equations by. So now I have a negative 72 and a positive 72. Look, negative 72 and a positive 72. What can I do for it to become 0? I'm going to add. Because when the signs are different, we add. Okay, let's add. Negative 63x, we're adding that to negative 32x. Negative 70 2, let me put this in a bracket, negative 72y, we are adding that to 72y, and this is equal to 81, and I'm adding that negative 76, all right? Let's put it together. When we add negative 63 and negative 32, we're going to get negative 95x. Adding same sign, we add, we keep the sign. The negative 72y and the 72y becomes a 0. So let's go to the other side. 81 with negative 176 will give us negative 95. So at this moment, I'm going to divide both sides by negative 95. So as you can see, x is equal to 1. So I've found x. X is equal to 1. Now, because I know that x is equal to 1, I could now use this to my advantage, okay? What I'm going to do here is I'm just going to quickly take this value for x, and I'm going to substitute this in any one of the equations. I'm going to use equation 1. It says negative 7x minus 8y, and this is equal to 9. The intention that I have is I'm going to substitute 1 right there. So let's go. Negative 7 times x becomes times 1, and this is equal to, well, minus 8y, which is equal to 9. Negative 7 times 1 is negative 7, minus 8y equal to 9. Let's add 7 to both sides. The negative 7 plus 7 becomes a 0, so I'm left with negative 8y, which is equal to positive 16. Let's divide both sides by negative 8. So y is equal to negative 2.